So we're here to solve the Skyscrapers variation with sums by Murat. The very first thing to do is to actually enumerate what the 20 and 21 options are. And a way to think about that is to recognize that the full sum of a row when it's the digits 1 through 7 will be 28. So 21 is going to be 7 away from a full sum, and 20 is going to be 8 away from a full sum. And in this full sum, we can't exclude the digit 7, the largest digit. That will always be seen in a Skyscrapers row or column. And so what we're really thinking about for the ways to sum up to 21 are the other exclusions with 2 digits or with 3 digits that remove 7 from the puzzle. Let's go through the 2-digit options first. 1 plus 6 is 7. So 2, 3, 4, 5, 7 is a way you could get to the sum by missing out 1 and 6. 2 and 5 is a sum that gets to that magic 21, so with 2 and 5 missing. And the last option that's taking out 2 digits is where we take out 3 and 4. And there's one more choice, which is where 3 digits are missing. 3 digits, 1, 2, and 4 add up to a total sum of 7. And so this last option is also possible. And notice that in all these options, the first digit is a 1, 2, or 3. And that's one way we can write at the start something like this. Not that we'll use this too much yet, but we'll see something similar coming up with the 20s, which will actually be how we begin. When we're leaving out 8, we again need to think about 2-digit and 3-digit sums that are missing, and the 7 is not a digit that can be missing. So in the 2-digit sense, there's no partner with 1 that's going to work, but 2 with 6 and 3 with 5 are both options that would add up to the right total sum. So this is the one without 2 and 6. This is the one without 3 and 5. And then there are 3-digit missing options where 1, 2, 5 or 1, 3, 4 are missing. And those equal these sets. This is the one without 1, 2, 5. And this is the one without 1, 3, 4. And again, 1, 2, 3 are at the start of these sets. So the very first thing to recognize then is probably in this row that's got 3 starts to clues. This 21 can only see one of these starting digits of 1, 2, 3. So it can't be 2 of 3, it can't be 1 and 3, it can't be 1 and 2. It can be 3, where the next digit seen is a 5. And there's going to be a hidden 4 somewhere in the sum, but the 4 can't be right here because it would be seen. So a 5 must be here. And then somewhere along this row will be a 6 followed by a 7, a hidden 4 in one of these spaces, and the remaining digits that start these 20s are 1 and 2. The thing to then take out is probably some of the impacts on these other clues. This 5 looks to be pretty important. In a 21, 3 of the 4 options included a 5. The only one left is 1, 3, 4, 6, 7. So we know that for sure actually right now. So it's going to start with a 1. It must see a 3. And so the next digit after the 1 will have to be a 3. It's now the case where the 2 is a hidden digit and can be anywhere in the row, but we'll start by marking something like this, and then think about this 21 clue isn't going to see a 6 right in its second cell. So this pushes up. This is 6. This is 7. There's an option of the 2, 4 in some space in that column, but this, it looks like we fulfilled this clue, and we fulfilled this clue. We've got a sum that's going to be coming from this 21, and it's not going to use the digit 3 because the 3 all the way over in the 6th column is going to be hidden. So 1, 2, 3 options are taken away. This is 1, 2, 5, 6, 7 for sure. So starting digit 1, next digit must be 2 because it's seen its position. The next digit can't be a 4. The 4 has to be hidden in this row, so it absolutely must have a 5, and then a 6, a 7 in one of these cells, and the 4 is hidden somewhere here. So again, we have basically used our knowledge of the limited sets of sums to get some progress. This one makes this 20 up top start with a 2, and this other 20 start with a 1. The 20s that start with a 2 are 2, 5, 6, 7 exclusively. The first digit after this, since the 1 is already hidden, will have to be the 5. And then 3, 4, 6, 7 come down below, but the 6 before the 7. With a 6 here, this must be a 6 in one of these cells, and the 7 must be in one of these cells afterwards for this sum to be done correctly. The sums that start 1 over here for 20 always will have a 2 or 3 in the next cell. And we'll have to think about the eventual sum that plays out, but a 4 is seen in these clues. So 4 will have to be in one of the first 4 overall cells to be seen. 3, 2, 4 or 1, 3, 4 would work, and 1, 2, 4 would work. And also the 7 at the end is going to be forced somewhere low. A thing to then think about, looks like this 21 is going to be also forcing. Second digit's 5, that's going to be seen. It's going to have to be 3, 5, 6, 7 coming up. That means at the top here, the 6, which could have potentially sat in the cell, would actually be hidden if it were placed here, because the 7 would be below it. So it's not the case that the 6 can go in the right. The 6 has to go in this cell. Trying to see if there's more we can intuit straight away. It actually looks like there's more I could have done over here, in part because a 21 that starts with 2 would have to have 3 as its next seen digit. If this were 2 and the next space is 4, that's not a valid sum. So there is an option where 1 is the first digit seen. That looks good. The next digit could be 2 or 3, but it can't be 4. So we're going to move the 4 down, put the 2 in. We now know that this is 1, 2, 5, 6, 7. So a 5 has to come in here, which we've now got. A 6 coming across, and then eventually a 7. And here again, the 6 preceding the 7 means this 6, which we wrote in as a notation, comes below. So we've got this fulfilled. We're going to have 1, 2, 5, 6, 7. The 6 can't be here, so this also has to be a hidden building. 6 and 7. That looks good. We're going to move the digits where they just intersected with knowledge we had. Got a 4 sitting up there. Let's come back to this 20 clue now that all the other buildings are effectively, well, I'll actually do this clue first because the 6 moves over 6 and 7 with 4, 3, 4, 3. This is the last building or last skyscrapers clue to finish. And it's a 20 that's got a 2 or 3 next. And it's going to be seeing this 5. And it's not going to be seeing a 6 because the 7 in this position could be here or here. It actually is already eliminated to be here because all these C4 or 5 total buildings. And with that, the sum that we need to make is 1, 3, 4, 5, 7, hiding a 6 and hiding a 2. And there's only one way right now to write that in the grid, which is 1, 3, 4, 5, 7 straight away. 6, 2 all after the 7. This 4 now comes over, and we've got all the 4s in the grid with this placement. We've got 2 6s, so this is the last position in this row that can take a 6. This is the last spot in this row that can take a 6. There's the 5. We've got a 1, 2 in these spaces, a 1, 2 in these spaces. Leaves behind a 3, 5 for this row, which has to go this way. Here's the 2 that now forces 1, 2, 1, 2, forces 1, and the very last digit 5 will finish this puzzle. So pretty tricky all around. It starts by being meticulous in writing out these 4 summation pairs, thinking about this top row and how a first digit of 3 with a set 3, 5, 6, 7 is forced there. Eventually using these same limitations, a 5 at the start of this column puts 1, 3, 4, 6, 7 here. A 3 over here, hiding a 3, puts 1, 2, 5, 6, 7 here. And so on, getting around the grid, eventually setting each of these clues. So a really limited solving path, a really challenging puzzle, but a brilliant 2021 themed skyscrapers from Murat. So hope you learned something about this puzzle and how to think about forced sums, and we'll see you again soon.